Hello. So yeah, James, it's me again, Innovation Project Manager at UK Power Networks and Show and Tell for CReDo Plus project, which is aptly named because it's an extension to the existing CReDo Climate Resilience Demonstrator, which I encourage people to go and have a look at, which is something that's already available for visibility on. This is a really exciting and innovative project that will provide self-serve modeling functionality in the hands of network planners so that they can identify the impact of future extreme weather events. So I'm going to hand over to Elliot Christou, who's from Connected Places Catapult, to take you through all of the exciting details in terms of the project and the problem and the solution that we're proposing. And he's going to bring it all to life. So over to you, Elliot.
Thanks, James. Hi, everyone. Yeah, I'm Elliot Christou. I've been the technical lead from Connected Places on this project, along with our other partners, STFC, the Science and Technology Facilities Council, and CMCL, who have both been doing a lot of the technical work over the years on CReDo. Next slide, please. So climate change, as we've already heard from various other projects, is expected to increase in severity and frequency of weather events. And we're already seeing that with the recent events like Storm Arwen and last year's heat wave. Along with the climate risks to individual assets and sites, there is also a growing awareness from the likes of the National Infrastructure Commission, the Committee on Climate Change, and the Joint Committee on National Security Strategy, as well as others, that we have a lack of understanding of the cascading risk of our connected infrastructure systems. And it's been highlighted that the energy sector is a part of many of these infrastructure interdependencies. Next slide, please. To answer this, CReDo aims to be a climate change adaptation digital twin that connects across organizations and sectors. By breaking down data sharing and sector silos, we can collectively understand cascading risk and how to improve overall system resilience and robustness so that we can make better coordinated decisions at the lowest cost. For the past couple of years, Connected Places has been funding and running a demonstrator project in partnership with UK Power Networks, as well as Anglian Water and BT Group, to model their combined electricity, water, telecoms network, which is shown on the right here. And we've also been looking in particular at how it responds to flooding events. With our system-wide impact modeling, we can, for example, see how localized flooding could shut down a primary substation, and this could lead to loss of power to a secondary substation. In turn, this could cascade across sectors to stop providing power to telephone exchanges and water boosters, potentially meaning a loss of electricity, water, and telecoms to customers. And of course, there'll be knock-on feedback effects into the energy system. Next slide, please. So we've been working with partners across research and industry to tackle the social and technological challenges of digital twinning, like data sharing, as well as impact, economic, and decision modeling. Our overall goal is to scale CReDo up. So we've developed a distributed data architecture, which you can see in front of you. And at the heart of that, and at the heart of CReDo, is an extensible knowledge graph technology so that we can scale to more network operators and their different assets, as well as different geographies, different use cases and climate events, and also make the system interoperable with other technologies. Next slide, please. As Barry Hatton, Director of Asset Management at UKPN, said in our recent film, the more participants, the better our understanding of the interaction between networks and the impact of cascading risk. And so our overall goal with SIF is to scale across the energy sector with the aim of building it out to business as usual when it comes to climate change adaptation, decision-making for resilience, robustness, and cascading risk. Next slide, please. Now, I want to give you a flavor of how CReDo works, and we'll go on to talk about the extensions we've proposed as part of CReDo Plus. So it all starts with data from different asset owners being combined into the CReDo knowledge graph. And you can think of this knowledge graph as like a connected database. From here, we feed in geographical weather data, like the height of the flood, to understand how each asset in the network is locally impacted with our asset impact models. Then we can run our system-wide models that cascade any failures or impacts through the rest of the connected networks. We could then use economic models to determine costs of the event to operators and wider society, and decision intelligence to identify coordinated mitigation strategies like co-investment in better flood defenses at critical sites. Their data and insights are then, of course, fed back to the users. They can be visualized with map and dashboard visualizations. We were really happy with the results, but we identified a scaling issue. Next slide, please. So these asset impact models actually require eliciting tacit information from experts like asset engineers and managers through workshops. And this is fine for research and demonstrator purposes, but it's not scalable in the long term for our network and system-wide ambitions. Next slide, please. So you might be asking why we've taken this expert-led approach to model building. Well, it's important to point out that whilst there may be records of historic failure data, a lot of the time, this type of granular information is not easily accessible in data systems, or it simply doesn't exist because the events do not happen often enough or may not have happened yet. And as we've heard from others about sample size and issues around that, this sparsity can make purely data-driven approaches like off-the-shelf machine learning applications a bit of a challenge. Next slide, please. So as described, the CReDo approach is to work with experts to build the asset models, but traditionally these sessions need to be carried out by specialists like industrial mathematicians and require valuable time from asset engineers. The output of a series of workshops is what's called a probabilistic Bayesian network model, and this will capture the likelihood and risk structure to an asset or site, including what it's dependent on in more of this network sense, and any mitigation strategies. Next slide, please. So for CReDo Plus, what we've proposed is to create a digital elicitation tool that puts the building of these asset models directly in the hands of the asset managers and engineers. And with this, we'll be able to scale across networks and across different climate scenarios. Next slide, please. So now here is the proposed CReDo Plus workflow with the extensions in orange. The idea we've been testing is that asset managers will build the model structures and then distribute a related digital questionnaire to engineers and other experts so that they can validate and fill in the parameters of the model. And these parameters will then be stored and aggregated, et cetera, et cetera. It's important to note that where historic data does exist, it can be combined with the expert opinions to make stronger inferences. So the output of the elicitation tool will be a growing hierarchical library of asset models for different weather events that could be generic to either a class of assets or bespoke to individual assets. These models can then be made available to the CReDo technology and workflow that I talked through, but could also be integrated into existing risk management software, such as things like CNAME. Next slide, please. I'm now going to go on to give an overview of our discovery phase activities, which we ran as an agile feasibility study to prepare for a small-scale end-to-end demonstration. We worked in 2-week sprints with bi-weekly stand-ups and a longer combined retro and planning session, all managed by Connected Places. We also worked collaboratively on a single SharePoint protected by multi-factor authentication and hosted by UKPN, so all findings were kept secure. Network data and engineering expertise was provided throughout by UKPN, and the rest of the team worked collaboratively across organizations to understand more about the assets, their vulnerability, how impacts could cascade, and all the data that's available. We also looked at whether the elicitation tool was the right fit for UKPN and for scaling across the energy sector. And we also looked at how we would integrate and extend the CReDo technology. Next slide, please. So as I've talked about, next slide, please. So as I've talked about, we've already made some good progress with flooding, and so we're keen to extend to other climate risks with the SIF project. What we found from early workshops with the asset managers was that extreme heat is an emerging risk that is poorly understood. In particular, Sophie Mott, head of asset strategy at UKPN, thought this risk was in need of innovation, and the CReDo Plus approach was the right fit due to a lack of historic data and the complex interdependencies, such as the derated network capacity, combined with the added demand from things like air conditioning during bouts of extreme heat. So we identified 4 main classes of vulnerable assets that impacted in different ways, and found that the underlying modeling principles are slightly different from our previous flooding use case. So this will be a good test of the extensibility of the CReDo technology stack. Next slide, please. We also conducted workshops and data requests to map out UKPN private and open data holdings and identified the data sources relevant to the project. Next slide, please. We conducted background research on climate and weather data and found that the UKCP projections are suitable for all of our early prototyping needs, but we also engaged with climate experts who might be needed for bespoke data in the future when there is more targeted use cases, such as including cooling effects of wind and soil temperature. Next slide, please. From our user research, we identified that asset managers and engineers are the main users, and that we need to codify vulnerability knowledge through the digital elicitation tool, but that the outputs from these risk models and the outputs from CReDo are much more broadly relevant to strategic planning and data teams. Next slide, please. We produced a full visual mock-up of the digital elicitation tool that captures the user requirements we identified. For the model builder shown in the top right here, this includes the need for a low or no code solution through some sort of graphical interface. So we've also mapped this into the technical requirements and identified existing technologies that we will test out in the next phase. It's worth noting that for the demonstrator, we will of course be building out only the core functionality for testing and validating with users instead of building a full production ready tool. So it won't look quite as impressive as what the team has mocked up here. Next slide, please. So in summary, we are extending to the extreme heat use case and have mapped out the asset and system vulnerabilities as well as modeling requirements. We know where to get the asset data and we know where to get the climate data. And the technical team have concluded that it is feasible to integrate and extend the existing CReDo technology. Next slide, please. So CReDo Plus is expected to bring a broad range of benefits to network operators, their customers, and wider society. Previously, frontier economics focused on assessing the benefits of an improved understanding of infrastructure interdependencies and how that will impact the strategic planning for resilience and robustness use case. They simulated that the expected benefits for the case of flooding over the investment period of up to 2050 are estimated for CReDo at around 100 million over the UK. They also found that CReDo would deliver a higher level resilience across the system at a lower cost relative to a counterfactual where there was only siloed resilience planning. Future work is of course needed to quantify the benefits of the extreme heat use case, as well as some of the benefits such as improved response, integrated adaptation reporting and price reviews, as well as other spillover effects such as better collaboration and information sharing between organizations, improved data quality, and better awareness of climate change impacts. Next slide, please. Our next steps are listed here. In addition to the technical work, we'll also be doing a lot more stakeholder engagement across the energy sector because we really need to test out our scaling and demand assumptions, as well as building out the business case. Next slide, please. And I wanted to finish by highlighting some of the complementary activities we're up to as our ultimate ambitions are to scale across sectors. So I'm pleased to share that we're in the process of kicking off a project with Angling Water and other partners funded by the Ofwat Catalyst Stream to explore connected extreme heat use cases in the water sector. This is, of course, highly complementary, and we're already feeding in some of our learnings from this discovery phase and expect to, of course, get those back as well. As well as this, at Connected Places, we're using our core Innovate UK grant to explore the cross-sector use cases for integrated infrastructure technologies and advancing towards an interoperable digital and data sharing ecosystem, which I'm showing on the right here. I think this is where a lot of the interoperability comes in and where different types of modeling approaches could be combined throughout the different use cases. Next slide, please. So thank you for your time today and to the other projects that we've discussed with over the discovery phase. If you're interested in finding out more, please get in touch or go to the digitaltwinhub.co.uk/CReDo for more information. So happy to answer any questions, and I might be drawing on my colleague Stefan for any further thoughts. Cheers.
Thanks a lot, Elliot, for a very thorough presentation. Well done for getting through all those slides. We're still waiting for questions to come in at the moment, but I was wondering if you could just share any learnings from leveraging different funding routes with the project as well. It's something that we're really enthusiastic about seeing, and it's great to hear that there is this being used between your core grants and the water sector. But sort of what are the challenges to practically doing that?
Yeah, so I think the first one is, of course, around that they both need similar types of climate data if we're focusing on extreme heat for both. So as I said, like we're taking on a lot of that learnings and all of the research that we've already done and the different experts that we talked to over the discovery phase around what would be needed for more advanced climate data beyond just UKCP stuff. I think the other thing that's interesting is around our modeling approach. So in the like earlier work that we've done around flooding, that's a lot more to do with, flooding is a very direct impact. So, something gets wet, it has to be turned off and it is down for a while. Whereas with something like heat, where it's a lot less understood, I think it's in part because it's a much more like prolonged process. So it's more about, multiple days or weeks where an asset is experiencing high temperatures, as opposed to, like an immediate effect from a flood. And this kind of approach will obviously be taken as well and shared between both projects, because we're looking for this kind of extensibility and interoperability. We'll be looking for that kind of meta modeling approach that can be applied to all different types of assets across sectors. So otherwise, like it's not going to scale.
Yeah, I got it. So you'd actually relates quite a lot to the technical approach to the project as well.
Exactly.
We've got a couple of questions that have come in now. One, how do you anticipate the ownership or commercial usage of the CReDo model working? Is this something that the network owns, or is it provided on a license basis?
Yeah, this is a good question, and I think one that comes up a lot. I guess it also relates to the kind of who pays question. So Connected Places are, of course, a not-for-profit, and this is really something where we're just pushing the technology and we're exploring all different avenues. There are various cases that this could take, and of course at this stage it's where we're seeking to leverage innovation funding. Could see that it's something that is like a software as a service model that network operators pay for, and this is something that we're exploring. It could also be something that's more owned by government and regulators, and it feeds more into things like adaptation reporting and price reviews, and having a consistent approach across that to understanding risk. There are obviously like quite private sector options around insurance and stuff like that, but for the moment, we're just exploring those, and that's part of our kind of other work that we're doing.
Brilliant. We'll be interested to see how that develops then. It feels like there could be some good learnings for other projects as well. We've got a question from Steph Church, which is, what approaches are to be used where there's less knowledge around some assets? Have you found any particular data gaps?
So what we have found is more that there's not a lack of knowledge about the assets, but there's more like a lack of machine readable knowledge about the assets. The data isn't like tabulated or well digitized. You hear a lot about resilience planning and things like that, that is still maybe as a PDF. And that obviously makes it a lot tougher. That's kind of why we've taken this approach of eliciting the knowledge directly from the experts, from the people with the boots on the ground that really know their sites and know intricacies that would actually be quite hard to capture digitally. And of course, the asset managers have a good handle on this as well. And these are the people that we've been discussing with over the kind of discovery phase.
Mm-hmm.
Maybe I can add a couple of things as well. I'm Stefan, data strategist from the Connected Places Catapult as well. So I think that the couple of things to also consider is that this elicitation methodology that we're aiming to use as a base to develop what Elliot was just presenting a minute ago is at the root of it is based on collaboration. So there's no reason, if you feel as an organization that you lack the expertise to perhaps produce a good quality model, that you couldn't necessarily find that expert knowledge by collaborating with some other organizations that perhaps you have collaborated in the past for other projects. So that could be academia or other things. And one of the things perhaps to mention here is that we're aware that probably hotter climates around the globe have more expertise on some of these heat event kind of impacts knowledge. And for example, we've got a virtual roundtable scheduled for later in the month with some of our contacts in the power sector in the US via some of our or some of our academic partners, where we're hoping to learn more and start to investigate these kind of like collaborative approaches. But I think that's an interesting one. And plus also, CReDo has been designed from its initial stages to be extensible and flexible. So I think, as a project, we're also very interested to see what other projects are doing in this sort of space. And, there shouldn't be a particular reason why there could be different kinds of models involved for different kinds of things should it be needed. So that's also one thing that I think we would be quite keen to understand and collaborate with others in the future, should the need for this sort of like question arise for some of the use cases. But yeah, thank you. Sorry.